Buenos dias, fuckers. Still very early. It's either very late or very early, whichever one you wanna go for. First up, I did a post earlier with the flat earth and I inserted some lines and said, when it's 12 o'clock up here, everybody's seeing the sun at 12, and then this side it'd be 12 o'clock at night. Now what I forgot to put in, I only put in 6 hours, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And there are 24. So I just thought I'd add that. I realised my own mistake, and I'm sure that Simon Dan also realised my mistake. So Simon Dan, stand your team down. I made a mistake and forgot to put 12 hours on the flat earth. So that is what we have. All of those lines, like that would be, what's that? So we have 0 and then 1, 2, 3, 4, all the way around, 24 hours. So when the sun is, say for example, here where I am, everybody, it's the same time all the way up to the North Pole. The sun, and I've seen the tropic of Capricorn. In the flat earth model, this is as far north as sun goes, right? Which is when Norway, which is there, sees the sun along its horizon for 24 hours, for quite some time. Now, if it was Earth spinning, it would be impossible for Norway to see a sun at the same level in the horizon, because Norway is offset. I've taken the thing off, so Norway is just above this one here, that's Norway. And as you could see, if it was a planet turning, so anti-clockwise, it dips below and then comes back up. So how do they explain, there it is again, how do they explain the sun in the horizon for 24 hours a day for a month and a bit? The only way that could happen is if they were on the center of the axis. Then, when Earth was spinning, you'd see a same uniform height. It has to be the sun turning around, spinning around Earth. It's one of those little things that it's quite obvious. There's Norway there, right there. Pink, orangey, pink one. Other one's Sweden, and then we have Finland. Now, anti-clockwise, if we are the sun right here, look, it disappears, it's gone. So now Norway is looking up for that sun in the horizon, but it has dropped below. And then it comes round and it pops back up. There it is. It doesn't matter where you put this, it can never have a uniform height all the way around, because it drops in and out. It's offset by 30, 20 something degrees from the top. It would have to be here. That's when you'd see an all day, all night sun. It's one of those little things. Now, fetch. I'm going to talk about the height of waves. Fetch. Wave height depends on 3 factors. Wind speed, how long the wind blows, and the distance that the wind blows. All of those things determine the height of the waves. No. No, they don't. Thought about this, right? It's got a lot to do with the moon's gravitational pull. None whatsoever. Personal experience, I have bombed it out in a tinny, little 4-meter boat, with a 20, 35, 30 on the back. The wind, but you skim across the top of the sea. Not always, but sometimes. So that straight away, it's got nothing to do. Height of the waves. Of course, if there's a cyclone or a hurricane, you've got a swell coming in, the tide's coming in, then you're going to get flooding in low-lying areas. But out the front is not the wind that determines the height of the waves. It isn't. It's one of those things that has been taught and we've all accepted, but thinking about it, tsunamis. So we have a tsunami happens, water cannot be compressed. You cannot compress water, okay? So what we have is the ocean floor, right? And the surface of the water. Let's say, I don't know, 100 feet, right in between. From there to there. Massive undersea earthquake. And crack! 2 plates have been fighting for years. One going that way, one that way. They shear. The pressure finally gives boom. And this one, this side, goes up. Boom! This one goes down or whatever, but this one just flies up. Bang! Straight away. Cubic centimetre for cubic centimetre, everything that rises there has to go somewhere. You cannot compress water. So you get this massive boom come up. Obviously some will go underneath them, but the shockwave, it's instantaneous. Bang! Water displacement. So what you have, a tsunami. Now these aren't rogue waves, but it is still nothing to do with any wind, right? Wind speed, how long the wind blows, and the distance it blows. A tsunami has about as much to do with the wind as the moon does gravitational pull on the water. That's one. Then we have the rogue waves. The rogue wave has absolutely zero to do with wind. Zero to do with the wind. So we've got tsunamis and we have rogue waves. Nothing to do with the wind. Now let's go and have a few minutes of popcorn moment. I'm going to listen to about 3 minutes, I think it might be. Right, this is now about rogue waves. It's all relevant, very relevant.
Seem to come from the same direction as prevailing wind or waves, which is why they've been the stuff of legends and
Hear that? They don't come from the same direction as the waves, as the wind. Rogue waves. Not ants. No. Don't do that. Freeze on me. Let me pause you.
Waves that follow predictable patterns.
Right.
Rogue waves are rare and often surprising. They don't seem to come from the same direction as prevailing wind or waves, which is why they've been the stuff of legends and maritime lore for so long. Technically speaking, when scientists talk about wave height, they tend to focus on the tallest 1/3 of the waves passing through a point in a given time period. They call the average of these the significant wave height. No matter the weather conditions, waves vary in size. It's those taller, significant waves that have the most energy and are most likely to cause damage. To be a rogue wave, the wave has to be at least twice as high as the significant wave height in the area. And throughout history, there have been many significantly larger than that. The first person to officially report a rogue wave was 19th century French explorer and naval officer Jules Dumont d'Urville, a botanist and cartographer sailing around the world on various expeditions. Dumont reported seeing rogue waves over 30 meters high in the Indian Ocean, a report bolstered by 3 eyewitnesses who'd been with him. Ultimately, though, his claims amounted to nothing. He was publicly ridiculed for his stories across society. Even the French Prime Minister voiced his disinterest in the stories. As such, in the decades that followed, the notion of a giant rogue wave sort of just disappeared. It wouldn't be for nearly 150 years that the phenomena crept back into the public domain once again. Skeptics agreed that waves of such a size simply did not exist, and if they did, then no one would survive long enough to return home and tell the tale. Waves are created as energy is transferred to the ocean through friction, caused by the wind blowing along the surface, as well as the gravitational pull of the sun and the moon upon.
Right there, folks. As well as the gravitational pull from the sun and the moon. Now, we must understand something here. Okay, now this has to be understood, folks, okay? It has to be understood. The bulge, spinning anti-clockwise. I have to repeat it. If there is a bulge along the equator, what on earth are the 4 highest tides doing at the top of the spinning planet? It's a rhetorical question. We do not need an answer because we know what the answer is. I don't know how many times. Number 1, Bay of Fundy, the highest tide, Nova Scotia, highest tide on Earth. Ungava Bay, the 2nd highest tide on Earth. The 3rd highest tide, the Bristol Channel. The 4th highest tide, the Cook Inlet in Alaska. These are up north, and when it spins, as you can see, they are all at the top. That is a clear indication that there is no bulge. There is no bulge. Not only that, along the equator, or just above the equator, we have the Gulf of Mexico, be about there, and over here we have the Mediterranean Sea, plus the Bahamas down here as well. It's a low tidal area. Bulge, it's so illogical that it's a slam dunk. There is no bulge. Those 2 things are enough to totally scrub a tidal bulge out. Not to mention, tide, when it comes in, I have to repeat this. Poof, stops for up to an hour, and when it recedes, it goes back same way it came in. How does that happen with a spinning planet and a moon that it's constantly on the move. There is no gravitational pull on our water by the moon or anything else. So that right there, when they say, because of the sun and the moon, whoops a daisy, is a big fat lie. There's no way that people believe this, the people, the teachers. Some of them might, but this is a deliberate lie. A deliberate lie to suggest round, the moon, gravity. Let's watch a little bit more.
On the Earth, this energy travels through the water as a wave until an obstacle eventually breaks it up or crashes into the shore. The reason then that scientists didn't think it was possible for rogue waves to exist was because they thought these waves of energy were linear, otherwise known as the linear wave theory. As such, the size of waves can be predictably calculated with some simple maths.
Here we go.
Therefore, the general scientific consensus at the time was that oceanic waves could only reach a maximum height of 9 meters. With the advent of steel-hulled ships in the 20th century, things changed, as the probability of surviving such an event increased dramatically, and so did the number of reported sightings. Indeed, between 1969 and 1994, 22 supercarriers were lost due to impact with rogue waves, killing...
Do you hear that? Okay.
...with sightings. Indeed, between 1969 and 1994, 22 supercarriers were lost due to impact with rogue waves, killing 525 people.
About one a year.
In 1978, the cargo ship MS München, then one of the biggest, most modern cargo vessels in the world, issued a distress signal at 3:10 a.m. on December 12th. That SOS call marked the last time the crew would be heard from ever again. The ship, bound for Savannah in Georgia, got into trouble in the North Atlantic under pressure from extremely bad weather. At over 240 meters long and 30 meters tall, the ship had been built to cope with waves of up to 15 meters and was widely considered unsinkable. Yet hours after the distress call was issued in the small hours of the morning, the rescue plane sent out to recover the ship found no trace of her or her crew. What followed was the largest search and rescue operation ever conducted in the North Atlantic.
I'm not going to see a lot of wave action. It would be good to, but it's not about that. What we have is a very, very clear, unmistakable few facts here. It has nothing to do with the wind. It has nothing to do with the gravitational pull from either the sun or the moon. I say it hasn't from the sun. We kind of know it hasn't because it's the bulge, isn't it? Everything is along here. But that's where the least action is. The top action is up top. So this fetch thing, it's not right. It's not right. And I know there'll be people out there, here he goes again. No, not here he goes again. I'm talking about the facts. Tsunamis and rogue waves, they have nothing to do with this. Like I said, I bombed out in a tinny, 4-meter tinny, 25, 30 horsepower on the back. And the wind, blow your house. But you skip across the water because it's flat. Not always, but enough times that you can say, well, hang on a minute, I have questions here. And there have been times where you go out there and it's a calm day. And the chop, it's like, boom, but you can't even get up to 3 knots because it's just, you turn around, come home. When there is no wind, the chop, the height of the waves may have, the wind might have a tiny bit to do with it, but skims across the surface, doesn't it? Something else is displacing lots and lots of water under the ocean. Same as with, it's not the tides, it's the tides are not being gravitationally pulled around. I'm going to show one other thing. I'm just going to pause you guys, okay? Okay, the Bay of Fundy. Now, moon dragging the water, the chaos, the dragging of the water. It'd be chaos, wouldn't it? Which part of the water of the ocean is it dragging? It isn't. Now, let's watch this. Right? Now, remember, something is displacing the water. Something way out there has to be displacing the water. Understand is it's all coming up at the same, it's organized, it's structured. There's no chaos. There's no chaos. The topography, the underground features, none of it makes any difference here. You can see that something is displacing the water. This isn't a gravitational pull. Look. And if it really were the moon, it wouldn't come up, get to the top, and stop. It would keep following the moon. It would rush around the land somehow, wouldn't it? But it doesn't. It stops. And there is a break, a pause. And then it drops and it goes back the way that it came. It's not the moon. chaotic. Well done, Morten Rusted. Now, we have to understand something. This is about trusting our own judgment, but for good reason. Okay? Everything, nothing points towards any gravitational pull from anything, folks, okay? It's not even a tricky one. It's all about understanding something. It's about understanding that this is it here. It cannot be. It's the fact that it's gone on for so long. It's an insult to humanity's intelligence, the way they pump it. The bulge, there's a bulge. There's a bulge. There is no bulge. There is no bulge. If there was a bulge, and it's no accident. This isn't an accident. This isn't, the more you think about it, it's obvious that people educate us. Bulge at the equator, but no, folks. This fetch thing, no. If there are high tides and a cyclone coming in, then yeah, you get a swell and you get the flooding of the low-lying areas. But the wind is not what is creating those crazy waves. Another thing. Let's look at the Atlantic, for example. Right? All that there. All of this. Right? Atlantic Ocean. All of that. Now, isn't it funny how all of these coastal areas, everywhere there's coastal areas, the waves go towards the shore, don't they? Now, why is that? Why don't waves, go down that way? Or so look, we're seeing waves go from the beach out into the ocean. They don't, do they? Wind or no wind. Wind even pushing out, you still have the chop coming in from somewhere to the shorelines everywhere. It's obvious, it's a common sense, it's logical, isn't it? Yeah, of course, the waves, but if it were something else, if it were, for example, the moon, when it moved away out into the open ocean, it would drag waves with it, wouldn't it? But it doesn't, because there is no pattern. There is no pattern. If the moon is ever above a high tide, it's a coincidence. Now, it's coming up to half an hour. I'm not going to really slam dunk this fetch thing. Say, it's a slam dunk, it's not the wind. But it isn't the wind, right? It isn't the wind. It might have a tiny little bit to do with it, but rogue waves, wind, the distance the wind's blowing, how long it's been blowing, tsunamis, the wind, there's no gravitational pull. Something else is displacing the water, and probably on a flat earth. All right, folks, 29:45. Have yourselves a great day. I might take some of the day off today to grind some stone down. All right, folks, I will be back. I'll be back.